All right, today we're going to start section 4.2. Let me switch to a bolder pen.
4.1.
Oh! 4.1, I was just checking to see if y'all were paying attention to what section we were on. Very good job. We are on 4.1. We will do 4.2, but it doesn't come first. All right, we're going to look at section 4.1, and in this particular lesson, we're going to do a lot of graphing. So all of the skills that we tried to master in Chapter 3 are going to come back and be helpful to us in this one. Or they're not going to be there and we'll have a problem. I hope that's not it. Okay, a couple of things I want to talk about. If you printed the class notes, you don't have some of this intro information. And you don't have to worry about writing it down either. It just helps me get you into the lesson. All right, all of Chapter 4 is about systems of linear equations. And a system of linear equations is a group of equations with the same characteristics, and the group is to be considered as a group. You take two equations, and we're going to work with them together. Okay? When we're going to work with them together, that makes it a system. In higher math classes, you look at sometimes systems of 3 equations. And sometimes each equation has an x, a y, and a z. So there are different kinds of systems. The ones that we're going to look at are going to have 2 equations. Each one of them will have x and y. We've been graphing equations that look like this. All right, now a little bit of practice to get ready. This is just getting ready. Let me ask you a question, and by the way, this, if you took Math 301 pre-algebra, you had a question just like this. It says, is x equals 3 a solution for this easy equation? Okay, and most of y'all are nodding your heads yes. So if I have 3 times the value of x plus 2, I'm checking to see if that's going to be a true statement or not. And I already hear some people saying that's 9 plus 2, and that is 11. So you said yes. Now, question, why or why not? Let's mark through the why not. Tell me why. How do I know?
Makes it a true statement.
It made it a true statement. When I substituted 3 in the place of x, it made a true statement. So I want you to attach that idea to the word solution. A solution is a value that when substituted in for the unknown makes a true statement. Okay? Now, I have to make this a little bit smaller on the screen. A solution to a system is an ordered pair whose x and y values satisfy both equations of the system. Let's look at some of my math lab questions that deal with determining if an ordered pair is a solution to a system. Okay, so I'm going to go to question number 1 in my math lab. So if you printed the notes, this is question number 1. If you did not print the notes, then as I write things, I'll write them larger and you can see what's going on. All right, I actually have 3 separate problems to do here. It says, which of the ordered pairs, and I have choice A, choice B, and choice C, which of the ordered pairs is a solution for this given system? All right, what does it take to be a solution?
A value that makes the statement true.
A value that makes the statement true. So let's start with the point 0, -2. And I'd like to test it and see if it is a solution. Well, I have to test it twice. I have to test it in the first equation, and I have to test it in the second equation. All right, let's try the first one. I have 2x plus 3y is equal to -6. And I'm going to plug in x is 0, so that's 2 times 0, plus 3 times -2. Does that equal -6? Okay, if I do that work, 2 times 0 is 0, so that term is gone. I have negative 6 is equal to negative 6, so it's true. And I know the following. The point 0, negative 2 is a solution to this equation. And if it's a solution to it, it means it's a point on the line. But what I'd like to know is it a solution to both of the equations? So I'm going to take 0, negative 2, and I'm going to plug it in. Negative 3x plus 5y is equal to 9. Oh my goodness. Hello. All right. Better. All right. Is equal to 9. Sorry, had a little blow up there. So that gives me negative 3 times 0 plus 5 times negative 2 is equal to 9. That's gone. Negative 10 is equal to 9. No. That's false. So the point 0, negative 2 is not a solution to this line. It means it's not a point on that line. So, looking at the entire system, is 0, negative 2 a solution to the system? No, because the definition of a solution to a system is that you must be a solution to both equations. So I know choice A is not the right answer. All right, let's take a look at choice B. I'm still working with the same system, but I'm supposed to test negative 3, 0. All right, I've already hearing some answers, so let's see. Is 2 times negative 3 plus 3 times 0 equal to negative 6? I just plugged it into this first equation. Negative 6, that's a 0. Is that equal to negative 6? Yes. The point negative 3, 0 is a solution to the first equation of the system. Let's see if it is a solution to the second line. I think I said first point of the equation. Okay, the second equation is negative 3 times negative 3 plus 5 times, okay, did it again. Zero is equal to 9. And negative 3 times negative 3 is 9. That's gone. 9 equals 9. Yes, if it is a solution to the first equation and it is also a solution to the second equation, then we know it is a solution to the both. It is a solution to the entire system. So choice B is correct. This only has one answer. So I don't need to test that one. I could, and something or maybe both of them would be false. Is that okay? All right, so for an ordered pair, in order to be a solution to a system, what has to be true?
Both statements.
Both statements have to be true. You have to be able to plug in the x and y of the point into both equations and get two true statements. You will have a test question that asks you to do that. Okay? Now, that's great for us to be able to determine if a point is a solution, but I need to be able to solve for a solution. So let's look at question number 2. For those of you looking at the projection, this is probably too small to read, but I'll read it out loud. It says to solve a system means to find the ordered pair that satisfies both of the equations. If a solution to one equation is a point on the line, then where would a solution to both equations be found? So let's think about that for just a minute. If a point is a solution to an equation, then it is literally a point on the line. If a point is a solution to a system, then that means it has to be on both of the lines. What's going on physically for a point to be on both of the lines? They're crossing. Exactly. I'm going to be looking for scenarios where I have intersecting lines. And I'm going to be trying to find the shared point. An intersection will be a point on the first line. It will also be a point on the second line. So we're going to be looking for a point of intersection. Okay? Now, in order to find my point of intersection, I'm going to have to graph very carefully. None of this sloppiness. Don't just haphazardly throw a line on there. I'm going to have to be very, very careful. And even being careful, sometimes I misread or I get off a little bit. So there are some risks when you do this by a graphing technique. All right, problem number 2. It says solve the system of equations by graphing. So I'm going to go down and get a little workspace, and the first thing I'm going to do is take the line x plus y equals 17, and I'm going to figure out how to graph it. In Chapter 3, we learned 3 techniques for graphing. General T-chart, a specific T-chart that had intercepts with the zeros, and y equals mx plus b, slope-intercept. I can use any of those techniques I want. Which one do you want me to use? Okay, I kind of push y equals mx plus b, and y'all pick up on that, and I will use it a whole lot today. Okay, she likes having the beginning point and then having some moving directions. I do too. But you know what? It's going to end up to not be a good technique for this, and I'll show you why. If I'm going to use slope-intercept, do you agree that I have to subtract x from both sides? Mm-hmm. And I get y is equal to negative x plus 17. Where would I begin for this graph? At 17? If this is y equals mx plus b, do you agree that I would have to begin at 17 on the y-axis? Look at what I have for a grid. Do I have 17 on the y-axis? No. Although 17 exists on the y-axis, it does not exist in my picture. So I can't do this. It's a limitation. I can't use it, I'm sorry. So if I choose to do the intercept technique, I'm going to run into the same battle. My intercepts are going to occur at numbers like 17. So I'm going to go back and say for this problem, and by the way, this is the only time you're going to have to do this in this entire exercise. But I'm going to make a general T-chart. The equation says x plus y equals 17. So just off the top of your head, would you give me 2 numbers that add up together to be 17? 9 and 8. I like it. What else could I pick? 10 and 7. Now you know with MathLab, how many points do you get to plot?
2.
2. So you wouldn't need any more. You would just need those 2. Okay? Just 2. Lots of times you find 3, but 2 is all you have to use. All right, if I'm real careful, maybe I can get by with just those 2. So, I'm going to put my grid up here. I'm going to enlarge this on the screen. All right, my 2 points were, what'd y'all tell me? 9 and 8. So, I go over to 9 and up to 8, and I've got a point. There's 9, 8. And then I had was 10 and 7. 10 and 7 is right there. So I've got 2 points. I get my straight edge. I try to be as careful as I can be. Now, you will have a slight advantage when you're using MyMathLab because when you click on those 2 points, it draws a perfect line for you. Perfect. My lines are not so perfect, so I get a little bit of error sometimes. All right, is everybody okay with that part? Now I need to go to the second equation. The second equation was x minus y equals -1. Now I can use any technique I want. I think slope-intercept will work for this one. So I'm going to subtract x from both sides. That gives me -y is equal to -x minus 1. And I'm not quite through. What else do I have to do? Good. Divide by the coefficient, which is a -1. So y is equal to, what's -x divided by -1? It is +1x. And -1 divided by +1 gives me +1. So I got a +x and I got a +1. Where will I begin? At 1. And how will I move? What's the slope? It is a 1 and it's over a 1, which according to my rise and run means up 1 to the right 1. Let me pause for a minute. Is that much okay? If you don't like slope-intercept, then you are more than welcome to do this T-chart technique for this one. It's totally up to you. So here I go. I'm going to graph that one. I begin at 1. I'm sorry. Let me enlarge that for us in the classroom. Okay, I begin at 1. My slope was up 1, right 1. Now watch what happens. If I just have those two, and I'm depending on my eyes to line this up, there's a lot of error I can make. So what I'm going to do is repeat that. The slope was up 1, right 1, up 1, right 1. I am just getting a bunch of little steps headed toward the line. Because what am I looking for? The intersection. You don't have to do that when you're doing MyMathLab, because the minute you get 2 points, it will connect them for you perfectly. I have the graph of the system. I graphed the first line using a T-chart. I graphed the second line using slope-intercept. I am looking for a common shared solution. Do you see a shared solution? Okay, and you need to name it as an ordered pair just like you did. It is the point.
8, 9.
It is actually 8, 9, because remember you have to say the x value first and the y value second, and it's a little bit hard to read. It will not be hard for you to read in MyMathLab. You could even blow it up and have it enlarged. I don't have it perfectly. I've got it just a tiny bit too low. But it is the point 8, and then it should be up there at 9. It should be 8, 9. Is that okay? So once you've done that part, you've drawn the graph, you'll then go over to where it asks a question, and it says, right down here, the solution of the system is, and it says, type an ordered pair, type in if there is no solution, we'll talk about that in a minute, type I if there are infinitely many solutions, and we'll talk about that. But we had a ordered pair, and you will type in 8, 9. Is that okay? Mm-hmm. Do you see why you have to be very careful with your graphing? You're going to do your homework on MyMathLab, but let me say this. Please don't show up to take a test over this lesson and never have graphed something on a piece of paper. That's one weakness to using MathLab to do your homework. It's a slightly different experience when you're doing it on the screen versus you're doing it on paper. So practice on paper. All right, let's look at number 3. Problem number 3 says, solve the system of linear equations by graphing. So I will take each one of the equations and write them down separately on my notebook paper. I have x plus y is negative 7, and over here I've got negative x plus y is positive 7. I'm going to go ahead and get all my work done, and then I'll go up and enlarge my graph and work on it. All right, first equation. What do I need to, do y'all want me to use slope-intercept? Okay, let's subtract x from both sides, and I get y is equal to negative x minus 7. Where will I begin? Yes, on the y-axis. And my slope is what? It is the coefficient of the x, which makes it negative 1, and it needs a denominator of 1. Because if you don't have a denominator, always put a 1. What moving in directions does that tell you? Down 1 and right 1. So I will use that information in just a minute to graph my line. Let's take a look at this one. In order to get y by itself, I will add x to both sides, and I get y is equal to x plus 7. Where do I begin? 7 on the y-axis. My slope is what? 1. Put it over 1. That gives you moving instructions of up 1. Up 1 to the right 1.
So on the other one, whenever you had a negative 1, the denominator doesn't need to be negative?
No, it does not, because the denominator, if you had put negative, then you'd have negative divided by negative, which would mean positive 1. And it wasn't positive 1. So anytime the denominator is not printed, it's always a positive 1. All right, let's go up and now graph the lines. I'm going to do them in order. I'm going to do the one on the left first. I begin at negative 7, then I go down 1, right 1. Okay. All right, begin at negative 7. So there's my first point. And I go down 1, right 1, down 1, right 1, down 1, right 1. I have the option, if I want to reverse the directions. Instead of going down and right, I can go up and left, which just gives me points in the other direction. I draw as many points as I feel like I need. I use my straight edge, and I missed them. And I've missed all my points now. All right, I'll give it a try. All right. I think this is better. Second line. I have a y-intercept of 7, so I begin at positive 7. From there, I move up 1, right 1, up 1, right 1, and so on. Let me try to go back the other way. Down 1, left 1, left. I'm just getting as many points as I can. Now, my first line was off a little bit. All right. I am having to cheat just a little bit. I'm dealing with not the best tools on earth. I've got to make it bold enough for you to see, and it messes me up a little bit. You want to use the best tools you can. All right, it is crossing at. You're not going to have trouble when you do it. Where do you think it's crossing?
0, 7.
Okay, you're on the right track. From the origin, I would have to go left 7, so that's negative 7, and then I wouldn't go up or down, so that's 0. It is the point negative 7, 0. Now, do you have any idea how to check and see if you're right? Plug them in. That's what we did for problem number 1, was checking to see if something was a solution. So you can plug in -7 for x and 0 for y in the equations, and if it's true, it's right. Is that okay? All right. Let's go to number 3. That was number 3. Let's go to number 4. Problem number 4 says solve the system of linear equations by graphing. So I'll go down, and the first equation is y equals 3x, and the second equation is 5x minus y is equal to 2. All right, on the first one, it's already in slope to intercept form because it has y equals. Where will I begin? At 0. And how do we know? There is an implied constant of 0 added on to that. The m value is 3. What do I put the 3 over? And how do I move?
3 and right 1. See, I didn't have no problem doing this. No problem.
Is the graphing. Okay, well, we're going to practice over and over and over. All right, the next one. This equation, I'm going to have to subtract 5x. I have negative y is equal to negative 5x plus 2. What's my last step? Divide by negative 1. Divide everything by negative 1. And I get y is equal to, what's a negative divided by a negative? Positive 5x. What's a positive 2 divided by negative 1? No. Negative 2. Divided by, yes. Okay? In other words, if negative y is negative 5x plus 2, positive y will be the opposite, positive 5x minus 2. So all you really have to do is just change all the signs.
Why did you divide by 1 though?
Because what was the coefficient of y?
Oh, okay.
Okay? So where will I begin?
Negative 2.
On the y-axis. And my slope value is,
5.
whoops, I almost copied down the wrong thing. It is 5. Put it over positive 1. So just like you said, it is up 5 and right 1. Is everybody okay with that information? All right, then let's go to graph. All right, my first line had a y-intercept or a beginning point at 0. And from there, I was supposed to move up 3 blocks, right 1 block. Whoops. I'm going to repeat that. Up 3, right 1. Up 3, right 1. Then I do my best to draw a line, which for some reason, doing it on this screen is messing me up. That was the first line. Yes, question?
What do you do that line?
Oh, okay. You only have to do it once. You only have to do the up and over 1 time. But I'm trying to line up my ruler just right, and so it helps me to repeat it several times and get more points to line up my ruler on. So it's all about me trying to get this, okay? Which you don't see me do because it doesn't project, but, pardon? I started at 0 because if we went back, if you could, the original equation is y equals 3x. And you begin, okay, I just heard the aha moment. All right, let me get that back on the... All right, line number 1, sort of okay. Line number 2, where do we begin?
Negative 2.
At -2 on the y-axis. up 5, which will put me there, and over 1, and I'm lucky. I landed on the other line. Now, you don't have to do this, but I'm going to repeat that. I'm going to go up 5 and over how many?
1.
1. And that didn't stick. Okay. Okay, I missed it. They intersect right here.
They're going to intersect it at
At the first
1
point.
and 3.
Yes, they intersect at the point 1, comma 3. You can do a better job on a piece of paper than I'm doing with this. I'm using bold marks. I've got this pen. I'm trying to see on a screen. So I'm handicapping myself a little bit. I'm giving myself excuses here. Okay, but the answer is 1, 3. But do you understand why you have to be very careful about the graphing? Because you're trying to read exactly where they cross. Graphing as a technique is wonderful because it's visual. You say, oh yeah, a solution is going to be a point that's shared, so I can see it. It's wonderful because it's visual. It's hard because it's tedious and it depends on exact actions. All right, let's take a look at number 5. And the nice thing about problem number 5 is that both of the lines are already in slope-intercept form. So if I have the first line is y equals negative x plus 1, and the second line is y equals negative 3x plus 5. Where will I begin for the first line? I will begin at 1, and I will move negative 1 over 1, which is down 1, right 1. There's a negative with the x. Where will I begin the second line?
5.
At 5. And my slope is, yes, it is a negative 3, put it over 1, which tells you to go down 3 and right 1. All right. Now, let's take that information and go back up to the grid. All right, my first line, I begin at 1, and from there I move down 1, right 1. If you're doing Math Lab, that's all you have to do, is click those 2 points and a beautiful line will be drawn. But I need a little help, so I'm going to continue with that down 1, right 1 to get myself a really nice pattern for a line. There's my first line. Second line, where do I begin?
5.
At 5. And
Down 3.
down 3.
And over to the right 1.
Whoops, again. I'm sorry, it's really cranky. All right, there's 5, down 3, right 1. And if I repeat that, down 3, right 1, I lost my first line, didn't I? Where did it go? There's my second line.
So it's gonna be at 2.
If you could see through my blobs, that would be actually right up here. It is the point 2, -1. Mhm. It is the point 2, -1.
Okay.
From the origin, it's right 2 and it's only down 1. That's where they hit.
Okay, I see.
They hit right there.
Okay.
Okay, so we could just keep doing this all day if we wanted to. We will finally see something a little different in number 6.
I like these.
These are okay. What this does is this really gives you a lot of practice as well as a real application for graphing. Okay, let's take a look. Let me shrink that one more level. The next one, this is number 6. It asks you to solve the system by graphing that has x plus y equals -3 and x plus y equals +3. Slope-intercept. Subtract x, and y is equal to -x minus 3. Where will I begin?
3.
-3. My slope is -1, so I put -1 over 1, which is down 1, right 1. Second equation. Subtract x, y is equal to -x plus 3. I will begin at 3, and I will move down 1 and right 1. Okay, what was your observation? Okay, it is. But we're going to keep that a secret for a minute. All right, he's already made an observation about this, but as a class, we haven't quite gotten there yet. Ready to graph? Okay, first one. I begin at -3, and my slope was what? Down 1, right 1? Okay, draw a line. Miss it. Try again. Close. The next one, the y-intercept is +3. I go down 1, right 1.
They're parallel.
They happen to be parallel. Now, if we had been extremely observant, look back at the work. Look at the slope values. Look at those m's.
They're the same.
They're the same. And when two lines have the same slope, they're parallel. Okay, now, parallel is not the answer to this question because the question didn't say, hey, what kind of lines do you have? The question said, what's the solution to the system? It's the intersection. Where do these two lines, they don't. Parallel lines, that's the definition of parallel lines. They don't intersect, but they're in the same plane.
So you put an N.
So you put an N. I will put an N on my picture, and I will put an N right there. The instructions tell me to either type an ordered pair, an N if there's no solution, or an I if there's infinitely many solutions, which obviously is coming up in another example. So is everybody okay with this? All right. Number 7. The system is y plus 5x is equal to 0 and negative 10x minus 2y is equal to 0. All right. I need to get this in slope-intercept form. So for the first one, I'm going to subtract 5x from both sides, and y is equal to negative 5x. Where will I begin? 0.
You can have just, I mean, it's already done.
It's already done?
I mean, the y, you can have just like, okay, 0's up here, so 0 will be my beginning point, and 5 will be up, and then put the 1 up here.
Okay, you'll have to be careful, because in its original form, this number 5 is not the slope, because it has to be in the form y equals. What happened is the 5 changed signs when it went to the side. So my slope is negative 5. Put it over 1, which means down 5, right 1. So you have to be careful. It looked like it was ready, almost, but not completely. Yes, sir?
Why is it always over 1?
It's over 1 if there is no denominator to the fraction. Slope is a ratio. It's a fraction. So it needs a top and a bottom. So the number 5, negative 5, if I just had to invent a denominator for it, the only number I can put down here and not change it is a 1. Because if I divide negative 5 by 1, I still get negative 5. Now, if it turns out that the slope is, say, 2/3, then I'm already in good shape. I have a 2 and I have a 3. But when you don't have a denominator, it's always positive 1. Always. Okay? The second equation, to solve it, I need to add 10x to both sides. That gives me negative 2y is equal to 10x. Divide by negative 2, and y is equal to negative 5x, which says, well, wait a minute. Look at these two. They are exactly the same. Now, they disguised this one so that it didn't really look like the first one, but when I got it in the y equals format, I see that it's the same. So if I graph the first line, don't I already have the graph of the second line? All right.
So they're parallel and they're not.
Okay, now let's be careful. Are they parallel? Not really. Because to be parallel, you have to be two distinct lines. All right, if I graph this, I'm going to begin at 0. I guess I'm graphing a red line this time. And I will then go what? Down 5 and right 1. And I get this falling line. If you're doing this in MATLAB, and you've got the first line drawn, and then you say, oh, the second line is the same, I'm afraid MATLAB is still going to want you to draw the second line. It's going to have to sense that you're doing it. So you would have to say, okay, I'm starting at 0, and then I have this point, and it would click, and it will simply superimpose the second line on top of the first line. But I think you're going to have to make the effort, because otherwise it will think you haven't finished the problem. If it's you and a piece of paper, you don't have to draw the second line because you've already got the picture. Now here's the question. What's the solution?
Is that the infinity?
This is the infinite solutions. My question would be, where do these lines intersect? Everywhere? At all of their points, at all infinite points. They intersect here and here and here and here and here and here, everywhere. They have an infinite number of solutions. MATLAB says to use letter I to indicate that. So I would go over and, yes, that'll be perfect for the test as well. Now, I'm going to skip over number 8 for just a minute. I'm going to come back to it, but I want to go to a screen that I have that you don't have. This is a drawing that's in your book. in your electronic version of the book. And up at the top, although it might not be visible on our screen in the classroom, it says, as we have seen, 3 different situations can occur when graphing the 2 lines associated with the equations of a linear system. This can happen, and this happens very, very frequently. The 2 lines intersect. And when you answer a system like that, you put an ordered pair. Okay? You have intersecting lines, and then you will name that point x comma y. Another thing that can happen to us, though, is that we can have parallel lines. What do you answer for this scenario? You answer no solution. So this one, you answer with an x comma y. And for the second one, you answer with no solution. For the third one, this is the third thing that can happen. You get the same line. And when that happens, you answer with I. You need to be aware of that. 3 different things can happen. You get an ordered pair, you get no solution when they are parallel, or you get infinite solutions when they are the same line. Those are the 3 scenarios that can happen. Pardon? The first one looks like intersecting lines. Yes, sir. And it's going to write on it this time. X comma y in I on the last one. Okay? So one of those will happen to you every time. Let's go back and look a little bit at number 8. The reason I put this one on here is because there's a fraction in one of them, and I don't want it to freak you out. So for my first equation, I have 6x minus y is 9. And for my second equation, I have 1/3 y is equal to -3 plus 2x.
What number is this?
This is number 8. All right. What technique would you like me to use? Slope-intercept again? Kind of stuck on it? Sure. So I'm going to subtract 6x from both sides. I have -y is equal to -6x plus 9. If -y is equal to -6x plus 9, what will positive y be equal to? 6x minus 9. I simply changed all the signs. Where will I begin? At -9. How will I move? I have 6 over 1, which is up 6, right 1.
Okay, I'm stuck.
Okay.
That was doing the way you were doing it a while
Uh-huh.
ago.
Okay.
So that would be -1 divided by 6 and -1 divided by 9.
Yes.
Okay.
And so,
So that would be -6.
no, you've got, look at this, you've got -6 over -1, be positive.
Okay.
And then you have positive divided by negative, and that'll give you the -9. Okay? On the second equation, oh my goodness, I don't want a 1/3 in there. What can I do to get rid of the fraction? Multiply by the least common denominator, which is 3. So I'm going to multiply 3 times 1/3 y equals 3 times -3 plus 3 times 2x. When I multiply the 3 times the 1/3, the 3's divide out, and I get y is equal to -9 plus 6x. Now, that's not the correct slope-intercept order. I need to swap positions with these two terms. So I'm going to have y is equal to 6x minus 9. The 6x went over here, and the -9 went over there. And what do you notice now?
They're the same.
They're the same. Just in the interest of time, I'm not going to graph these. Okay, I'm just going to tell you. You tell me, when I graph them, what kind of picture am I going to get? Tell me about the two lines. They're the same.
Infinite.
And so the answer to this is infinite solutions. Okay, and I'm just skipping doing the graph. Anybody have a question about using graphing as a technique?